Good morning, grade 9. Today, we will start the fourth quarter with our geometry course, which talk about circles. You can find it in your book, chapter 12, in the geometry book. First, we're going to start the lesson with some important definitions about circles. As we see here in this circle, we have the main point of the circle, which is called the center of the circle. This is the center of the circle, and you can name the circle according to the name of this center. So, in this circle, you can call it circle C. And now, look at this segment. This segment from the center to any point on the circle is called radius. So if you have any segment from the center to any point on the circle, you can call it radius. Another definition, chord. What is a chord? It's another segment, but its two endpoints lie on the circle. As we see here, the endpoints of this segment lie on the circle. This is called chord. And this chord didn't pass through the center. What about if this chord passed through the center? It's gonna be diameter at this one. So the diameter is a chord that passed through the center, and it considers as the longest chord in the circle. Let's see another line. This line is called secant. The line which contains a chord, as we see here, this is the line and contains a chord. So we have here chord, diameter, secant. These two are segments, but this one is a line. And now, identify the chords, radii, and diameters from this circle. Please try to do it by yourself, solve it in your copybook, and we're going to discuss it, inshallah, in the next conference. Another definition. If you have a line intersect with the circle at only one point, like the blue line, this is called tangent. What is the tangent? It's a line intersect with the circle at only one point. And this point, as we see here, this is the point of tangency. Look at this circle. We have here a polygon inside this circle. And the vertices of this polygon, the red points here, these red points are called vertices of the polygon, lie on the circle. So you can name this inscribed polygon. Inscribed polygon. Another definition. Can you see this red part? This red part is called an arc. Arc BC. It's a part from the circle. Any part from the circle, you can call it arc. And we can write it as it is. Arc BC. You should put this arc above the name of the arc. Arc BC. And now it's your turn. Identify two different arcs from this circle. Try to do it and also write it in your classwork copybook to discuss it together, inshallah, in the conference. Another definition. What do you see here in this circle? we have an angle VAC, or you can name it angle A. Angle A, its vertex at the center of the circle, and its two rays as two radii in the circle. So it's called central angle. The central angle, it's an angle with vertex at the center, as we see here, and the rays intersect the circle, as we see here, and form an arc BC. We finished our important definitions, and now we're gonna start our theorems in this quarter. We're gonna have some important theorems about circles, and we're gonna start the first theorem, which is Theorem 12.1.1. 12 refers to the chapter 1, which is lesson 1, and this one refers for Theorem 1. Chapter 12, Lesson 1, Theorem 1. If you have a line intersects a circle, this line will be a tangent if there is a radius perpendicular to this line at the point of tangency. So, if you have tangent intersect with a radius at the point of tangency, they will be perpendicular to each other and forming here right angle, which is equal 90 degrees. So in this theorem, we must have tangent intersect with radius to form this angle. Let's see an example. In circle A, and we name this circle A because the center is A. AB is a radius. If you see here, AB is a radius. CB is a tangent. CB, the green line here, is a tangent. So we have radius and tangent. Find what's this? How can we read this? M means measure. Find, measure, angle, this sign for angle, measure, angle, ACB. Can you tell me where is angle ACB on our figure? ACB. The place of the angle, it's at the place of the vertex. You can know it from the middle letter here. Can you see this letter? C at the middle. It refers to the angle. So this is the angle that we want to know. Find this angle. Okay. First, can you see this triangle? Triangle ABC. We have here triangle ABC. In this triangle, we have three angles. Angle A equals 60. Angle B and angle C. From Theorem 1, we took that if you have radius intersect with a tangent at the point of tangency, they are forming here right angle. They are perpendicular to each other. So, angle ABC, this angle, equals 90. So we have angle A 60, angle B 90, and the unknown angle here, how can we find it? Yes, if you have triangle, we know that the sum of measures of any angles in any triangle give me 180. So angle A plus B plus C give me 180. So we can calculate angles. Angle C, measure angle C equals 180 minus the measure of the two angles, 60 plus 90, to calculate the unknown angle equals 30. So we found now the measure of angle C, 30, A, 60, and B, 90. If you add them together, give me 180. Another theorem, theorem 12.1.3. If we have a circle, as we see here, and there is an exterior point out of the circle, and if you have two tangents intersect at this exterior point, here we have two tangents intersect at an exterior point, these two tangents, they will be congruent. What is the meaning of congruent? They will be equal in length. If this tangent, for example, 3 centimeters, this one also gonna be 3 centimeters. These signs means they are equal in length. This is theorem 3. Let's see an example. Here we have RS and RT are tangents to circle Q. Here we have circle Q, RS and RT tangents in the circle. From the theorem, we said that if we have two tangents intersect at exterior point, they will be congruent to each other. They're gonna be equal to each other. He asked me to find the length of RS. If you know the unknown variable here, N, you can find the length of RS. For example, if you find the value of N 2, RS gonna be 2 plus 3 give me 5. So we want to find the value of this variable to know the length of RS. We're gonna start solve this problem using the previous theorem, which is this tangent is equal to this tangent. So the the length of this tangent, 2n minus 1, equals the length of the tangent n plus 3. So we're going to write this equation, 2n minus 1 equals n plus 3. As we see here, the two tangents are equal and their measures in length are equal. And now we have an equation in variable n. First, we're going to collect all the variables in the left side and the free numbers in the right side. So subtract n to be 2n minus n and add 1 to be 3 plus 1. Now we have equation, the left side with the variable, the right side with the free numbers. Let's continue. 2n minus n give me n. 3 plus 1 give me 4. Now we got the value of n, which is 4. Now you can find any of these tangents, RS or RT. Why? Because now you know the value of n is 4. He asked me to find tangent RS, which is n plus 3. Substitute n with 4 to be 4 plus 3 equals 7. So the length of RS equals 7. Thank you for your listening. See you inshallah next conference. Study this video hard to discuss it together inshallah. See you. Bye.